Hello, and welcome back to the Maths Behind the Economics YouTube channel and the Logarithms for Economics series. This is video 18, and this is the first video of the practice questions when we will look at economics-based questions. So we're going to work with variables and expressions that are mostly common in economics. And again, just like in the previous practice questions, at each question I will explain to you which rule am I using and why. Let us get started. So, the first question is ln 120 e to the minus 0.45. So what can we do with this question? Well, I've noticed that there is a multiplication in the argument of the log, so I can use the multiplication behind the log sign rule, which we covered in video 8. So let us do just that. So I've got ln 120 plus ln e to the minus 0.45. Right, what can I do next? Well, ln 20, I can't really do anything else with it other than putting it into the calculator and finding the number that's hiding behind. But with ln e to the minus 0.45, I've noticed that there is an exponent behind the log, so I can bring that down just like we discussed in video 10. So I'm going to bring down the negative 0.45 as a multiplier, and then I'm going to left with ln of e. Is there anything else I can do? Yes. First of all, there is a bracket and there is an adding a negative times something. So ln 20 stays, but adding this negative is just going to give me the minus 0.45. But now, what is ln of e? Well, ln of e is just 1, just the way that we discussed it in the special logs video 5 and 6. So the final answer is ln 120 minus 0.45. Now, this is an exact answer, but is a difference. If you actually wanted to express this as one number, then you can just put it into the calculator. And the rounded answer to this would be 4.34 to 2 decimal places. Question number 2. I've got log and a long fraction, 1 plus r to the 6 over 1.975. Okay, what can I do with this? Well, let's try to break this out into individual log sign and try to replace everything we can with numbers. So first of all, I recognize that there is a division behind the log sign, so I can apply the rule that we covered in video 9. So this will be log 1 plus r to the 6th minus log 1.975. What's next? Well, there is an exponent in the argument of the first log, so I can bring that exponent down as a multiplier. So this will be 6 log 1 plus r minus log 1.975 equal, and then follow through in the next line. Well, the first term I can't really do anything with because there is an addition behind the log in the argument of the log, and there's no rule for the addition. Besides, there is an r in there, so that's a variable which value I don't know. So the first term is just going to be 6 log 1 plus r, but the second term is minus log 1.975. Now remember, if I know the base, which is 10 in this case because log is base 10, and if I know the argument, which is 1.975, I can calculate the number that is equivalent to this log expression. So let's do that. Pick up the calculator, and log 1.975 is actually 0.296 to 3 decimal places. And in the previous example, I rounded to 2 decimal places because there were 2 decimal digits in the expression. But in this example, I rounded to 3 decimal places because there were 3 decimal places in the original expression, like 1.975 here is 3 decimal places. So I'm just keeping in line with what the question is doing. So question number 3. I've got ln 200 times 1 plus 0.07 over 4 to the 4t. Now, what can I do here? Again, this is similar to the first example. in a sense that I have got a multiplication behind the log sign, so I can break that out as addition of the same logs. So I can write ln 200 plus ln of 1 plus 0.07 over 4 to the 4t. Let us make a bit more space and carry on down here. ln of 200 is equal to 5.30 to 2 decimal places. I'm going to write down here so we know that we rounded to 2 dp, because the calculator gives me 5.298 and 8 is telling me to round up, but from 29 is 30. So let's remove this side note. So that was ln 200, but now what else I've noticed that in the second term, the ln bracket to the 4t, the 4t is the exponent, so I can bring that down to the front. So I can write 4t ln 1 plus, and again, I've got 0.07 divided by 4, which is just 0.0175. Now, there's one more thing that I would like us to do here. This addition we can carry out. So this would be 1.0175. So then what we have here is 5.30 plus 4t times ln of 1.0175. But what I've also noticed here is that this ln 1.0175, I've got the base, which is e, and I've also got the argument, so I can calculate this value too. So let's do that. Pick up the calculator, and the calculator gives me 0.0173. Because the original expression had 2 decimal places in it, I'm going to round everything to 2 decimal places in the final expression as well. So that means I'm going to have to look at this 7 and I'm going to have to round up. So I've got 5.30 plus 0.02 times 4t. And again, the last thing I can do, and this is going to be the simplest form now, is leave the 5.30 alone. Plus, I can multiply the 0.02 and the 4 together, and that's going to give me 0.08t. Now, let us just stop here for a moment and see what we've actually done. The original expression was this. This is a relatively complicated expression which has got a log in there, and it's also have got some exponents. But this is equivalent to this very simple linear expression. This is exactly the same as 5.30 plus 0.08 times t, not forgetting that we rounded everything to 2 decimal places. So we can be a little bit more exact in our calculation if we were to round to more decimal places. Sometimes in economics you work with 4 decimal places, sometimes you work with 2 decimal places. It will depend on the context, so I suggest that you know clearly which rounding is expected of you. However, the main point remains the same. If you know how to work with logs, you can make complicated expressions very simple. Okay, let us make some more space and move on to the 4th practice question of this video. And for that I have got log a e to the I t. Wow, I've got loads of letters flying around in here, but let's see if we can make them a little bit simpler. So, same logic. There's a multiplication in the argument, so I can break that out as addition of the same logs. So what I've got here is log a plus log e to the I t. The next thing that I can do is I've noticed that in the second log term, there's an exponent, and that exponent can be brought down as a multiplier. So the first will not change. It's log a plus it times log e. And I'm going to stop here. The reason because I'm going to stop here is because in my videos, log is base 10. Now, you might come across some economics texts where they use log, where I would use ln. If that's the case on your course, then you might see that sometimes from this form, they just end up with it, and you wonder what the hell has happened to loge. Well, in that case, loge is just cancelling down to 1. Remember, ln of e is always equal to 1 because e to the 1 is equal to e. if your textbook's using log as the equivalent of ln, then that's basically going to give you the same result. That's why sometimes this loge just disappears from some text or from some exercises. Anyway, that was a side note. For us, log is base 10, so we're just going to leave the expression as loga plus it loge. And now, because I have made a lot of side notes, I'm going to need a bit more space to be able to finish off the video for today. So, fifth and last question for the video, log 1.00 times 1 minus 0.026 to the t. Okay, so let's stop and try to make some sense of what's happening in here. Well, first of all, you might see this 1.00 and you ask yourself, what is going on in here? Why is it 1.00? Why can I not just write 1 in here? Well, in some scenarios, in some economics calculations, you need to keep to the money notations, the currency notations. And the currency notation is always keeping every number to 2 decimal places. But then you might ask yourself the question, what's going on in here? Why do I have 0.026 in here and not just 2 decimal places, 0.03? And that's a very good question. But if you have some idea of what this formula is, then you kind of remember that this is actually a percent rate. And percent rates you usually keep to more decimal places. So that's why there's a little bit of a jumble of a notation in here. But aside of that, let's see what we can do with the numbers. So again, I have got log1 plus log1 minus 0.026 to the t. Okay, so let's move on down here. log1. What is log1? Well, if you remember from the special log videos, video 5 and 6, this is just equal to 0 because any base, which is 10 in our case, raised to the 0 power is always going to be equal to 1 and the logs are always the exponents. So the question is, what power do I need to raise 10? So the answer will be 1, which is the argument, and that is equal to 0. So log base 10 1 is always equal to 0. So that's going to be 0. I'm just going to put it out there so we don't forget why the log1 disappeared. And again, sometimes this might happen in your textbook or your lecture notes that a log expression just disappears, and that might be it because that log expression actually is 0. But never mind. What we have got now is we've got an exponent in the second log term, which we can bring down as a multiplier. So it's going to be t times log. But now in the bracket of the log, I'm going to have just a simple subtraction of 1 minus 0.026. Okay, so what I've got here is t times log, and let's do that subtraction, which is going to give me 0.974. And as the last step in our calculation, I can just calculate the rounded version of this log expression. Now the calculator gives me minus 0.01144110. And because the final answers in these kind of calculations are usually a currency that you look for, we probably do best if we round to 2 decimal places. So that's going to be minus 0.01 of t. And now again, this long and complicated log expression, if you know how to deal with logs, will simplify down just to negative 0.01 times t. How about that for simplification? Okay, well, I hope you liked this video. I hope you picked up some tips and tricks along the way. In the next video, we'll be doing more of these kind of logarithmic questions using variables from economics. I hope to see you there. Bye.